Bismillahirrahmanirrahim. We'll continue doing 4.3. Let me just revise what we have in 4.3. We have the definition for linear combination. When we say W is a linear combination of vectors, means there are scalars. So that's C1 V1 plus C2 V2 plus blah blah plus CK VK is equal to W. And then we talk about this idea of the span, linear independence. This is the general definition for linear independence. And then we go to this one, which is how to check vectors are dependent or linear independent or linear dependent. Let me repeat what we did. If the number of vectors is more than n, where n is the dimension of Rn, the vectors are in R3 and R4, all these things. If the number of vectors is greater than n, then right away they are linearly dependent. No need to do anything. If the number of vectors is equal to n, I have n vectors in Rn, then through the determinant, I check the determinant. Determinant equal to 0, then they are linearly independent. Determinant is equal to 0, they are linearly, if the determinant not equal to 0, they are linearly independent. If the determinant is equal to 0, then they are linearly dependent. The last case, if the number of vectors less than n, what I need to do, I need to take sub k by k matrix, submatrix. Then I check the determinant. If the determinant non-zero, right away they are linearly independent. If the determinant is not is 0, they need to check another submatrix until you take all of the cases of the submatrix, which is sometimes not easy to do. So it means what? I need to go back to the main definition. Okay. Now let us do these problems. We did those. Now we reach this one. I have how many vectors? 3 vectors. I have 3 vectors in R4. Means which case? We are in this case. 3 vectors in R4. So what I will do, I will list them. Okay. You take submatrix. For example, let me take this submatrix. See what will happen. So I have determinant 1, 0, 1. Submatrix 3 by 3. Which is K, this K, 3 by 3. So I have 0, 2, 2, 3, 0, 3. Check the determinant. I have what? 1, 0, 1, 0, 2, 2. Multiply by minus 3 and add, that will be 0. Minus 3 and add, that will be 0. Minus 3 and add, that will be 0. So I have what? Yeah. If I do the expansion of what? 1, 0, 1, 0, 2, 2. Yeah, 1, 0, 1, 0, 2, 2. 303 044. Okay, I took this, multiply by minus 3 and add, it will be 0. So the determinant is equal to 0. Yeah, since this is all of this are 0, so the determinant, we cannot conclude anything. Yeah, you need to check other submatrix. Take this, and maybe I need to take the first with the third and the fourth. So you need to check all of these possibilities. Or since I'm not getting non-zero, I'm not getting this case, a non-zero determinant. So you need to go back to the previous way, which is through the Gaussian elimination, try to find the C's. Or more than that, actually, if you look at these vectors, it's very clear. I have U plus V is equal to W. Yeah, 1, 0, 0, 2, 3, 0, 0, 4, which is this one. So they are linearly dependent. For sure, they are linearly dependent, just by inspection, just by looking. Now let me do the C case, which is, we know it, 1, 0, 1, 022, 303, 044, 0000. I'm solving this. C1U plus C2V plus C3W is equal to 0. I'm trying to solve this system. Okay. So now what I will do, multiply the first row by -3 and add it to R3. Okay, to get what? 101. This is 0. This is continue as is. Multiply by -3, 0, 0. Then I have 0, 0. And this is 0, 4, 4, 0. Okay, that will lead us to what? I have 101, 0. I divide by 2, second row, 0. Yeah, half R2 and 1/4 R4. 0, 1, 1, 0, 0, 0, 0, 1, 1. Now multiply the second row by -1 and added the fourth row. I have what? 0, 1, 1, 0, 0, 0, 0, 0. Then I have 0, 0, 0, 0. Now we are almost done, so I'll change it into equation. I have C1 plus C3 equals 0, and C2 plus C3 equals 0. So that means I have C2 equal minus C3, and C1 equals minus C3. Okay, now if I let C3 equal to 1, I'm getting what? C1 equals C2 equals -1. So I have minus U1 minus U, semiconjugate U, minus V plus W equal to 0. Or in other words, W is U plus V, which is this one. Yeah. So they are linearly dependent. Okay. Assume that the vectors are linearly independent. Show that these three vectors are linearly independent. What I need to do, I think I need to go to the basic one, C1U1 plus C2V2 plus C2U2 plus C3U3 is equal to 0. I know what? If since V1, V2 are linearly independent, that means what? F C1, V1. This is what I'm reaching. This is what I will reach. C1 plus C1 plus V, C1 V1 plus C2 V2 plus C3 V3 is equal to 0. Right away, if I have a constant times V1 plus another constant times V2 plus a third constant times V3 is equal to 0, right away, those constants should be 0. Since he said V1, V2, V3 are linearly independent. Okay, now let us work it with use with these U1, U2, U3. So apply to have C1, V1 minus 3V2 plus C2, V1 plus 2V2 plus C3, V1 plus 2V2 plus 3V3 is equal to 0. Okay. Now, what is the coefficient of V1? V1 will comes from where? I have C1 here. Here I have C2. Here I have C3. What is the coefficient of V2? V2 I have here minus 3C1. Here I have 2C2. Here I have 2C3. What is the coefficient of V3? I don't have V3 here. No V3 here. I have only 3C3 equals 0. Since V1, V2, V3 are linearly independent, that means their constant, their coefficient should always be 0. So I have what? C1 plus C2 plus C3 equal to 0, which is the coefficient of V1, minus 3C1 plus 2C2 plus 2C3 equal to 0. And the last one, 3C3 equals 0. Now I need to solve this system. You can solve it different ways. One way, just solve it as an equation. From here, I'm getting C3 equals 0. By the way, these C's are different, huh? So I have, let me call it D1. Yeah, to avoid confusion. So any constant times V1, any constant times V2, any constant times V3 means those constant. If that combination is equal to 0, it means those constants are 0. And this is what we did. Okay, C3 equals 0. Plug it here and there. You're getting what? C1 plus C2 is equal to 0. And minus 3C1 plus 2C2 equals 0. So this one gives me 3C1 plus 3C2 and minus 3C1 plus 2C2. Add them, you get what? 5C2 equal to 0. So C2 equal to 0. Plug it. And that implies C1 equal to 0. Means U1, U2, U3 are linearly independent. Let me explain what we did to check whether they are independent or not independent. I'll go with the basic idea. I need to write the linear combination C1 U1 plus C2 U2 plus C3 U3 and try to find those C's. I found them, they are zeros. And I use this relation because he said assume the vectors V1, V2, V3 are linearly independent. It means any constant times V1 plus any constant times V2 plus any constant times V3 is equal to 0. It means those constants are zeros. And this is what will happen when I plug the definition of U1 and U2 and U3, and I took V1, so I have this is the constant times V1, this is the constant times V2, this is the constant times V3. So I have equations, C1, C2, C3, I solve them, I get all of the C's are 0, so they means the U's are linearly independent. The same idea again. He said V1, V2, V3 are linearly independent. That means what? If D1, V1 plus D2, V2 plus D3, V3 is equal to 0, that means all of these constants should equal to 0. Now, let us try C1, U1 plus C2, U2 plus C3, U3 equal to 0. Plug the C's and the U's. V1 plus V2. V1 minus V2. And the last one, 2V1 plus V2 minus V3. Okay, now look at the constant times V1, which is what? C1 plus C2 plus 2C3. Those times V1. Maybe I wrote it this way better. Plus, now times V2, C1 minus C2 plus C3 times V2 is equal to 0. And the last one, I have for V3 minus C3, V3 equal to 0. We know if you have a constant times V1 plus another constant times V2, a third constant times V3, then those constants, this linear combination is equal to 0. And since V1, V2 are linearly independent, since V1, V2, V3 are linearly independent right away, it means the constant should be equal to 0. Here I'm getting C3 equal to 0. Plug it there. I'm getting what? C1 plus C2 equal to 0. C1 minus C2 equal to 0. So I'm getting 2C1 equal to 0. If I add this, means C1 equal to 0, means C2 equal to 0. It means U1, U2, U3 are linearly independent. Okay. Now just this is also a quick review of what we did. We define what we mean by W as a linear combination. This is, we have this relation, this linear combination. When they are dependent, if I can find C's, not all 0. So let's have this linear combination is equal to 0. And linear independent, if I say all the possible C's are zeros. Okay, it means all the C's are zeros. Test for linear independence, if I have K vectors in Rn, we solve the system, we'll find the C's. If equal n, then the determinant will help. If K is less than n, also you have this, just to remind you, if K is greater than n, number of vectors greater than n, then they are linearly dependent. Is less than n, then I need to deal with this submatrix. Let me do more problems. Okay, what we have here, determine whether vectors are linearly independent or linearly independent. If they are linearly independent, then write one of them as a linear combination of the other. Okay, yeah. What we have here? Okay, how many vectors we have? We have 4 vectors. 4 vectors. 3 vectors, sorry. 3 vectors in R4. 3 vectors in R4. That means what? Means, well, in which case? Number of vectors is less than 3 vectors in R4. So we'll check determinant 1, 1 minus 1, 1, 2, 1, 1, 1, A1, 4, 1. See, can I take submatrix 3 by, yeah, if I take 2, this, yeah, be not. Let me check. If I take, see what will happen. I usually have some matrix. If it works, then okay. If not, then it means we need to do it. I find the determinant. I'm taking some matrix 3 by 3, huh? 3 by 3, okay. That is equal to what? 1, 2, 3, multiply by -1 and add, that will be 0. By -1 and add, that will be -1. By -1 and add, that will be -2. By 1 and add, that will be 0. By 1 and add, that will be 3. By 1 and add, that will be 7. So I have what? That will be -7 plus 6, which is -1, not equal to 0. It means since this submatrix is not equal to 0, then determinant of that submatrix, that means V1, V2, V3 are linearly independent. You can check it through the C's, solving this. See, what are the C's? All C's should be 0 for these 3 vectors. If you want, we can check that. Yeah, let me check that. 1, 2, 3, 0. 1, 1, 1, minus 1, 1, 4, 1, 1, 1. 0, 0, 0. So multiply minus R1 plus R2, R1 plus R3, minus R1 plus R4. We're getting what? 1, 2, 3, 0. I have what? 0, minus 1, minus 2, 0. I have 0, 3, 7, 0, 0, minus 1, minus 2, 0. I can multiply by minus to make this plus. So now I do minus 3 R1 minus 3 R2 plus R3 and R2 plus R4 to get what? 1, 2, 3, 0, 0, 1, 2, 0, 0, multiply by minus 3 and add, that will be 0. Minus 10, and that will be 1. I have 0 here. I have 0, add 0, 0. So I'm getting what? I'm getting the equations C1 plus 2, C2 plus 3, C3 equal to 0. C2 plus 2, C3 equal to 0. C3 equal to 0. So C3 equal to 0, plug it in the equation before it. I'm getting C2 equal to 0. Plug both the first equation, I'm getting C1 equal to 0. So for sure, V1, V2, V3 are linear independent. Actually, you don't need to do all of this. Huh? This is just a check. Okay. Whether the following are linear independent within vectors. Okay, how many vectors you have? 3 vectors in R4. So we need to do this submatrix way. Is it the same? Almost the same. 1, 2, 1, 0. 1 minus 1, 0, 1. 3, 0, 1, 2. I think we did it before. I saw those ones. Okay, let me do it, no problem. Yeah, I'll take a submatrix. I take this one. Submatrix. 3 by 3. Okay, and it's by the determinant 1, 1, 3, 2 minus 1, 0, 1, 0, 1. Okay. I need to add more zeros. So multiply the first one by 1 and add it to the second one to make this 0. So I have minus R1 plus R2, plus R1 plus R2. You get what? 1, 1, 3. This will be 3. This will be 0. This will be 3. That will be 1, 0, 1. So I'm doing the expansion now with the third row, with the second column. So I'm getting what? Minus determinant 3, 3, 1, 1, which is 0. So I cannot conclude, no conclusion. I need to check another submatrix, which is now will make it complicated. What I will do, I will go to the long way. I need to check C1, V1 plus C2, V2 plus C3, V3 equal to 0. And solve this system, which is this one. 0, 0, 0, 0. So multiply the first row by minus 2 and add it to the second row, minus R1 plus R3. To get what? 1, 1, 3. This is 0. This will be 0. Minus 2 and add, minus 2 and add, that will be minus 3. Minus 2 and add, that will be minus 6. This is 0. Minus 1 and add, that will be 0. Minus 1 and add, that will be minus 1. Minus 1 and add, that will be minus 2. And this is 0. That will be 0, 1, 2, 0. Okay, I can multiply this second row by minus 1 over 3 times second row. I'm getting what? 1, 1, 3, 0, 1, 2. The third one is 0, minus 1, minus 2, 0, 1, 2. So multiply the second row by plus R1 and add it to R3 and minus R2 plus R4 to get what? 1, 1, 3, 0. I have 0, 1, 2, 0. I have 0, 0, 0, 0, 0, 0, 0, 0. So I'm getting these equations, C1 plus C2 plus 3C3 equal to 0, and C2 plus 2C3 equal to 0. Which very clear, I have infinitely many solution. I have C2 equal minus 2C3, and from here I'm getting C1 equal minus C2 minus 3C3, which is what? 2C3 minus C3. So take C3, let C3 equal 1. I have C1 equal -1 and C2 equal -2. So I have this relation minus V1 minus 2V2 plus V3 is equal to 0. So they are linearly dependent. Okay. Show that these are formal basis. Before we prove the formal basis, we need to prove that they are linearly independent. I have how many vectors? 1, 2, 3, 4 vectors in R4. Okay, so which case? I have this case. Number of vector is equal to n. I have 4 vectors in Rn. How to check? Right away the determinant. Now I have a matrix 4 by 4. Check the determinant. What do you think? Easy one. 2, 0, 0, 0, 0, 3, 0, 0, 0, 0, 7, 6, 0, 0, 4, 5. I can do the expansion for the first column. Huh? I'm getting what? 2 times the remaining, which give me 2 times 3 times 35 minus 24. It's very clear not equal to 0. So that means V1, V2, V3, V4 are linear independent. So it means they form a basis. Since I have 4 vectors, 4 linear independent vectors, and R4. Remember, we said that, I think. Let me double check. Yeah. Yeah, we said it in 4.2, I think. Yeah, if on 4.1, if we have the number of vectors are n and Rn, and they are linearly independent, then they form a basis. Okay, now we want to try T as a linear combination of these vectors. Since they are bases, so it means they can be written as a linear combination. So I have T, which is 1, 2, 3, 4. Okay, so I have what? 1, 2, 3, 4. And it's to be C1, 2, 0, 0, 0 plus C2. I need T equals C1 V1 plus 2 V2 plus C3 V3 plus C4 V4. That's C2 0, 3, 0, 0 plus C3 0, 0, 7, 6 plus C4 0, 0, 4, 5. Okay, let me see the equation. I have 2C1 is equal to 1. Okay. Yeah, let us make it, yeah, I think it will be either this way. Then I have 3C2. I don't have, okay, is equal to 2. Then I have what? I have 7C3 plus 4C4 is equal to 3, and 6C3 plus 5C4 is equal to 4. Okay, this one is very clear. C1 equal half, and this is C2 equal to over 3. Now we need to solve this two equations. 7C3 plus 4C4 equal to 3. 6C3 plus 5C4 equal to 4. I can multiply this by -6, and this is by 7 to get what? Minus 42 C3 minus 24 C4 equal minus 18. And then I have what? 42 C3 plus 35 C4 equal 28. Now I add these two. This is cancelled. I have 11 C4 equals what? 10. So C4 yeah, What a nice numbers. 10 over 11. I plug it in one of these equations to get C3. So I have 7C3 plus 40 over 11 equal to 3. So 7C3 equals 3 minus 40 over 11. 33 minus 40 is minus 7 over 11. So that means C3 equal what? Minus 1 over 11. So I have C3, I have C4, I have C1, I have C2. That means T is equal half V1 plus 2 over 3 V2 minus 1 over 11 V3 plus 10 over 11 V4. Okay, so I can write T as a linear combination of those vectors. Let V1, V2, U1, U2 be vectors. If V1 are linear independent, show that U1, U2 are linear independent. I have V1 and V2 linear independent. That means what? If I have this relation, that implies the C's, let me call it these. D1 equal D2 equal to 0. Now I need to check this. How to check? I solve this system. C1 U1 plus C2 U2 is equal to 0. That means what? C1 V1 plus V2 plus C2 V1 minus V2 is equal to 0. So I have C1 plus C2 times V1 plus C1 minus C2 times V2 is equal to 0. Since V1 and V2 are linearly independent, it means the constants should equal to 0. If I solve this system, I'm getting to C1 equal to 0, so C1 equal to 0, so C2 equal to 0. It means U1, U2 are linear independent. Okay, now we'll go to the old exams. He said, I have now, he gave me 4 vectors, are linearly independent. Then find what? Yeah, we have a good number of questions. Let me say it. I have the vectors. If these vectors are linearly dependent, I have 4 vectors, 3 vectors in R4. 3 vectors in R4. Okay. 3 vectors in R4. If I list it, I have 1, 1, minus 1, 1, 2, 1, 1, 1, 3, 1, A, 1. If I took this submatrix, for sure the determinant should be equal to 0. Because the determinant not equal to 0, then this will not be, it will be linear independent. So let me check this determinant. I have 3 by 3 submatrix. Let me see what will happen. I think I should get the answer. Let me see. So multiply by 1 and add. By minus 1 and add, that will be 0. Minus 1 and add, that's minus 1, minus 2. By 1 and add, that will be 0. By 1 add, that will be 3. By 1 and add, that will be 3 plus A. So this determinant should be equal to 0 for the 3 vectors to be linearly dependent. So I have what? Symbolizing minus 3 minus A plus 6 is equal to 0. So I have minus A is equal to minus 3. That means A is equal to 3. And that's the answer. Okay, assume the vectors are independent. Show that this one, I think we did something similar. Or we did it the same one. Yeah, I think it's the same as this one. V1 minus 3 V2, V1 plus 2 V2. Yeah, they are exactly the same. So done before. No need to do it again. And you notice this has been done. When was the exam written one? This one, I think we did something. We did it before. Yeah, which is this one. So no need to do it again. I know why this repetition. Okay, done before. The idea is very clear. Now, let's continue with, I think what's good if we have multiple choice questions, because the exams will come with multiple choice questions. Okay. Which pair of vectors in R3 are linearly independent? Yeah, let me do it backward. I think this is by inspection, huh? Or just by looking. If multiply this by -5, I have -5 V1. It will be -10, 5, -15. -10, 5, -15. So this is 5. This will be V2. So they are linearly dependent. This one, I can write V2, 0 V1. So they're linearly dependent. Okay. This one, I think I need to divide by 6. If I divide by 6, I have 2 over 6, 1 over 3. This is -1 over 6. 3 over 6 is half. So 1 over 6, or the other way, 6 V2, 6 V2, will be 6 times those numbers, will be what? 2 minus 1, 3, which is V1. Or we can say V2 is 1 over 6 V1, it's okay. So they're linearly dependent. This one, very clear, 8 times 2, huh? 2 V1 is equal to V2. So they're linearly dependent. This one you cannot. So they're linearly independent. You cannot find the constant times the first equal the second, or the other way. What you understand is true about the following vectors. They have how many vectors? 3 vectors in R4. I have 3 vectors in R4. Okay, so I need to check through this, through submatrix things, see what will happen. So I take a submatrix. Let me take this submatrix. See what will happen. The determinant will be what? I think the determinant will be 0. So yeah, this submatrix will not help, because I need to prove that they are linearly dependent. You can check it, but for sure, yeah, you should get 0. So I need to do it the wrong way. I have C1 V1 plus C2 V2 plus C3 V3 equal to 0. So I need to solve the system. 3, 0 minus 4, 1 minus 3 minus 6, 4, 2 minus 3, 2, 4 minus 2, 0, 0, 0, 0. Okay, how to solve the system? I can interchange this one. Okay. I can interchange R1 with R4 to get what? 1, 2 minus 2, 0. 0 minus 6, 2. Minus 4, 4, 4, 0, 0. 3 minus 3 minus 3, 0. Okay. Now multiply the first one by 4 and add it to the R3, and minus 3 times R1 plus R4 to get what? 1, 2 minus 2, 0. This is 0 minus 6, 2. I try to avoid the fraction. Multiply by 4, that will be 0. 8 plus 4, that will be 12. Minus 8 plus 4, that will be minus 4 times 0. Okay, this is 0. Minus 3, that will make it 0. Minus 3, that will be minus 9. Minus 3, minus 3, and add it, that will be 3. Okay. Now, I can divide, the second row by minus 1 over, by half or minus half, let me see, by minus 1 over 6. Let me get rid of this to get what? 1, 2 minus 2. I have a fraction, it's okay. 0, that will be 1. That minus 1 over 3, that will be 0. The rest are the same. Yeah, it's a matter of calculation. Huh? So I have 1, 2 minus 2, 0. Now multiply the second row by minus 2 and add it to the third row. And 9 R2 plus R4 to get what? This will be the same. Yeah, this will be 0. Minus 12 and add that will be 0. Minus 12, that will be 4. That will be 0. This is 0. By 9, that will be 0. 9 times minus 1 over 3, that will be minus 3 plus 3. That will be 0. So I'm getting this. So I'm getting C1 plus 2C2 minus 2C3 equal to 0. And C2 minus 1 over 3 C3 equal to 0. That means C2 equal 1 over 3 C3, or I can write C3 3 C2. So I write everything in terms of C2. So you have C1 is equal to what? Is equal to minus 2 C2 plus 2 C3, which is 6 C3 minus 2 C2, which is 4 C3. So for sure they are linearly independent. Means they are. So if I let C1 equal 1, I'm getting what? Yeah, he wants C3 to be 1. Okay. C1 equal C2 equal 1. He wants V3 to be 1. Huh? Yeah, so let me write it. I'm getting 1 over 3. Yeah. If C3 equal 1, that means C2 equal 1 over 3. And yeah, that will be very, very complicated. But the C2 equal 1. C3 will be 3. And C1 will be, wait a minute, this is C2. I'm writing everything in terms of C2. Huh? Yeah, C3 equal 3 C2. I have, no, wait a minute. So C3 is equal 3 C2. I have 6 C2 minus 2, that will be 4 C2. And C1 will be 4. So they are linearly dependent. And for sure, none of these, because this is 1 over 3. If I'm making it is equal to 1, I'm getting 1 over 3, so I have fraction here. Okay, so this will be the correct one. A value of k for the following vectors are linearly independent. How many vectors I have? 3. I have 3 vectors in R3. That means what? Right away I can use the determinant. K0, K, 2K, minus 3, 4, 3, 5, 2. Yeah, maybe we can multiply the first row by minus 1 and add it to the third row to get rid of, make it 0. So I have what? K, 2K, 3. That will be 0. Huh? Minus 2K, that will be minus 3 minus K. 3 minus 3, that will be 2. No, wait a minute. This will not change. Sorry. Multiplying minus R1 plus R3. So it will be 0. That will be 4 minus 2K. I have minus 3 plus 2. That will be minus 1. Now this determinant should be equal to 0, since they are linearly dependent. So I'm getting what? 3 minus 5, 4 minus 2K. That should be equal to 0. So I have what? 3 minus 20 plus 10K is equal to 0. So I have 10K equals 17. So K equals 17 over 10, which is this one. W, which is 158, equal A times V1 plus B times B2 plus T times B3. Sorry for that. So I have minus 1, 2, 3, 3, 1 minus 2, 2, 3, 0. This is 1, 5, 8. This is what I want to solve. Oh, that give me what? 1 minus 3 minus 2 minus 1. This will be the same. Now multiply by minus 2 R1 plus R2 minus 3 R1 plus R3 to get what? That will be 0. That will be 7. That will be 7. That will be 7. Multiply minus 3 and add, that will be 0. By minus 3 and add, that will be 7. Minus 3 and add, that will be 6. Minus 3 and add, that will be 11. So now multiply by 1 over 7. The second row. Let me do it in steps. 1, 1, 1, 0, 7, 6, 11. So multiply the second row by minus 7 and add it to the third row to get what? 0, 1, 1, 1. Minus 7, that will be 0. That will be minus 1. Minus 7. That give me 4. From here, I'm getting, yeah, this is the C. This is A, B, C. Huh? So I have A minus 3B minus 2C equal minus 1. B plus C is equal to 1. Minus C equal to 4. So I'm getting what? C equal minus 4. And C and B equal 1 minus C, which is 5. Okay. And plug it here. And A will be equal to 3B plus 2C minus 1. 3B, that is 15. Minus 8 minus 1, that will be 6. So A equals 6. B equal 5. Minus 4. So the answer is 15. Sorry for the confusion at the beginning. Yeah, these are the questions from the book. Yeah, we have good number of questions. I think I will leave it for the next recording. Thank you. Let me stop the recording.